I'm just trying to go live. Give me a couple of minutes, right? Let's just see if everything is working all right as we expect. Okay, I'm just trying to see if everything is as expected. Just give me a couple of minutes. Okay, I guess I'm live. Yeah, I can also hear myself fairly clearly, so no issues whatsoever. Hey, good morning everyone. So yeah, let's wait for others to join in. As usual, I've come a little early. Hey, very good morning folks. Thanks for joining in. As usual, I've come a little early just to ensure that there are no technical hiccups before we get started. Since I'm a little early, we'll start the session just after 10 a.m. So if you have any question, AI in general, right? So that other students who have joined the live session also would benefit. Hey, good morning folks. Thanks for joining in. So somebody says he's a B.Sc stat student. What could be the average compensation that he can expect? Again, as a B.Sc stat student, I'm assuming that your statistics knowledge is pretty good, but you also need to be pretty good with programming, because I am assuming that in B.Sc stats you may not have encountered as much programming as a typical B.Tech student would be. And typically in the industry, if you're coming from a B.Sc type of course, right, you're typically expected to a master's degree, because a B.Tech is like a 4-year course, while B.Sc in India is a 3-year course. So my recommendation, of course, you can get jobs with B.Sc also. I'm not saying you can't, but you'll most likely you'll most likely start your career with a data analyst type of job, unless you're brilliant, right? Again, the compensation itself will depend on both your ability to solve real world problems, your depth and breadth of knowledge, right? Those are two things that matter a lot. But in general, what we recommend B.Sc students is to also pursue masters, like an MSc in statistics or MCA in computer science, etc. So that because recruiters typically ask for a 4-year degree or more. A B.Sc is typically a 3-year degree, but again, it is possible for you to get a data analyst type of roles, but your compensation will be slightly on the lower side as compared to an MSc stats or MSc math or MSc physics or MCA, etc. right? So I would recommend you pursue a master's program and parallelly learn machine learning, AI, and also preferably become good at programming, because I've seen a lot of stats folks who are brilliant with statistics, mathematics, etc., who lack programming ability. But for a data scientist, you need to be good at both, right? Folks, please don't spam by repeatedly posting the same question. It's very distracting, both for me and most importantly for the other students. Please don't do that. So somebody says, how is applied AI course different from IISc? It's a very different league altogether. Again, we have many students from IISc who joined the AI course. In a typical master's program at IISc, you learn lot of, again, at an institute like IISc, when you pursue a master's degree, the focus is lot on theory. There is a lot of focus on theory. To be honest with you, at IISc, one of the most important lessons I learned was advanced mathematics and how to read a research paper. The practical aspects of machine learning itself, I learned in the industry, to be honest. I mean, I still remember my early days in the industry where I didn't know how to solve real world problems, even though I knew all the mathematics behind many techniques, right? So what IISc teaches you is it gives you very strong foundational mathematical and theoretical knowledge. And of course, you also learn not just AI subjects, you learn subjects like data structures, algorithms, operating systems, you learn maybe a distributed systems course, you learn a wide spectrum of courses, because in 2 years you have so much bandwidth to do. And most master's programs in India are very focused on theory, not as much on practical aspects. That's why we have a lot of students from IISc, other major IITs, both students pursuing B.Tech and M.Tech, and especially M.Tech in areas like AI, etc. Because the professors at university are phenomenal with theory. Right? So they learn theory from the university, they learn some of the theory, and most importantly the applied aspects the real world problem solving skills from the AI course. So I would look at both of these as complementary and not in conflict with each other. So, okay, so what are the next questions here? Okay. So I didn't understand this question. How to learn NLP from beginning to advanced? Again, NLP is just, again, there is a classical NLP, right, which typically is covered in university courses, where you start with stemming, stopping, all of that stuff. But today in industry, a lot of NLP is done using both classical techniques and, very importantly, state-of-the-art deep learning techniques, right? So the best way to learn NLP is to start with learning machine learning and deep learning, because that is almost the foundational stuff on which most NLP techniques can be easily built on top of. For example, I have never taken an NLP course myself, even in the university, but I've learned most of it on the job because I had a very strong foundational machine learning and deep learning knowledge, right? And again, the cutting edge of NLP is all deep learning. It's all techniques like attention models, transformers, BERT, etc. Again, many of them we cover as part of our course itself. As a non-computer science student, how to improve programming skill? It's fairly simple. Programming is just like, let's say, going to a gym, okay, or reading. How do you become good at reading? You become good by doing it over and over and over and over and over again. Even when I remember learning programming in my 11th class, if I'm not wrong, because I was in a B.Sc curriculum where we had computer science or programming as one of the subjects. So the only way I became good at programming, I really enjoyed programming even in my 11th and 12th, even in my B.Tech days or even after that. The only way people become good at programming is by solving lots and lots of problems by writing code. So first step is always writing lots of programs. Again, we have as part of the AI course itself, in the Python module that we have lot of optional assignments, especially targeted towards non-CSC students who are not comfortable with programming, right? I strongly recommend, if you're coming from a non-programming background, please solve all of them so that you become comfortable with programming. You have to become comfortable with programming because it is like reading, right? See, in your career, you have to be good at being able to read anything that is given to you. I think programming is such a foundational skill for your career now, whichever career path you're taking, that it is almost like a core skill. That's why even schools are encouraging. I see a lot of schools who are starting basics of Python programming from 6th grade onwards, right? So it's only through practice, number one, but after having done lots of practice, the second step is to read others' code. That's another strategy that works phenomenally well, and I have learned how to write beautiful code, how to write code elegantly by reading other solutions. Right? These are the two steps that you have to do day in and day out. You only become, unless you're super smart, which most of us are not, let's be realistic there, you become good at programming through practice. Nothing beats that. Okay, I think this thread has gone too far away. I cannot keep track of everything. Again, whatever questions I could not answer here, please feel free to shoot an email to team@appliedai.course. We'll try to answer as many questions as possible because there is a specific theme behind this live session itself, right? So I would like to focus on that specific theme itself. Again, we'll start in a minute or so, and it's impossible for me to answer this huge thread of questions. But anything that I could not answer, but you want an answer, please shoot an email to team@appliedai.course and we'll try to answer as soon as possible. I'll take one more question, then we'll start the session. Yeah, so somebody says, what about PyTorch? Especially people who are in deep learning. PyTorch is certainly a very popular and fairly widely used deep learning library itself. As part of the course, we focused more on TensorFlow and Keras, primarily because we wanted to pick one. Okay, of course, we will probably do a live session on introduction to PyTorch also, so that people who want to use PyTorch also can get started with it. But we had to pick one to write all of our code in. And both TensorFlow, again, Keras is now deeply integrated into TensorFlow. So let's call everything TensorFlow plus Keras as one bucket and PyTorch as other bucket. Again, PyTorch is used for production in companies like Tesla, Facebook, etc. TensorFlow Keras is used in production like companies like Google. So both of them are very, very production ready. There are thousands of researchers working and using these toolboxes every now and then. It's just that one is built at Google, the other is built or maintained and contributed by folks at Tesla and Facebook. So you can pick and choose. Again, I have not used PyTorch. I've used PyTorch in its early days. I haven't used it much more recently, but I've used TensorFlow Keras. Again, you can pick any one of them. Better still, if you know the basics of both of them, you should be able to read code of either TensorFlow Keras school or the PyTorch school, right? It's good to know both. I know the basics of both, but I've not used PyTorch myself in practice a lot as much I've used Keras and TensorFlow. So just my bias, but you can pick any one of them. Both of them are being used by thousands of researchers and on like crazy production systems. Okay guys, so since we are just overshot, we are just past 10, let's get started with the live session itself. I have some notes that I've prepared. I'll also focus, I'll just go through the notes quickly, but I'll focus more on the code itself. Let's do line by line code walkthrough today. Okay, so let me share the screen. I hope everybody can see the screen. Let me just refresh it to make sure that everybody can see the screen. Okay, so this is what I had in mind. So I've just written some notes, but before that, let me just see if everybody can see. If you, can you guys just confirm? Can you guys just confirm if you're seeing the live session or not? Okay, you're seeing the screen, right? So that's good. I just wanted to make sure. So I'll try to spend as much time. I'll just go through these notes, and once I go through these notes, I'll also go through line by line of code, right? I wanted to do a code walkthrough. But before we go through a code walkthrough, let me just give you a couple of interesting and important pointers. So the topic today is using web APIs in Python for machine learning, and we'll do it for two primary tasks, right? So the first primary task is using pre-existing models, using models built at companies like Google, right? So this is the first task that we will solve. Okay, how can I use the speech to text? Again, I'll take the specific example of speech to text model that Google provides as part of Google Cloud API, right? And how do we use it? That's the first thing. The second thing that we'll see is how to obtain data. Again, data is the new oil, right? Without data, you don't have machine learning and deep learning models. So we will use Bing through Azure API. Again, Bing is the second most popular search engine through Azure API, right? Azure, which is also owned by Microsoft, so is Bing. So we'll use the Azure API to get search results for a given keyword. So again, we'll do both image search and text search. So these are the two things. Again, here you'll know how to use Google Cloud, or especially the API part of Google Cloud, and you'll also learn how to use the API part of Azure. That's the whole agenda. There are also some assumptions that I'm making. So again, my biggest assumption here is you know how to write code in Python. You know how to write code in Python. You know what is an IPython notebook, right? Again, I'll be using Google Colab extensively today because it's easy for you to copy it and run it in your own Google account, right? Instead of you having to install, there are no installation headaches that way, right? Of course, you can run these notebooks, download them, run it on your own desktop or laptop. That's fully possible. But giving you a Google Colab type of environment helps you run it out of your Google Drive without any installation headaches, right? So these are the fundamental assumptions that I'm making, that you know Python, you know what is an IPython notebook, and you know a little bit about Colab. Even if you don't know too much about Colab, I'll give you some quick intro to Colab itself. Colab is again a tool by Google, very, very powerful, very popular, being used extensively by many students now. Okay, now the agenda is threefold, right? First is, what is a web API? Again, many of you know about Python functions. I'm assuming that you know Python, right? So I'll try to compare and give you a very high level overview of what a web API is. There are a lot of internals of how web APIs work using REST, using XML, right? Using service-oriented architecture, all of these things. I'm not going to go into all of the more technical or software engineering aspects of it. I'm going to give you an intuitive idea of what a web API is, and that intuitive idea is sufficient for the code walkthroughs. Okay, I'm not going to go into the software architecture stuff because this is not a software architecture or a software design course. Okay, as long as you know how to use web APIs, you're cool, right? So so I'll give you a brief introduction to what web APIs are. Then I'll go through a code walkthrough where we will take speech and we'll convert speech to text using Google Cloud API. Okay, this will be a code walkthrough. Then there is another code walkthrough, which is how do you collect data using Bing Search API, which is available on Azure. These are the three things that I wanted to do. First, let's understand what is a web API so that we can take the learnings from this and learn and actually go through the code, right? So let's go step by step quickly. So we all know about function calls in Python, right? How does a function call work? Imagine this is my Python code, some lines of code. Here I'm calling a function f with a parameter which is, or arguments, or parameter called Srikanth, which is a string here. So as soon as I call this function, what happens? See, this line is executed, this line is executed, this line is executed, this line is executed. As long as I call this function, what happens? It goes to wherever the function definition is, right? It goes to this. This Srikanth is now copied into this variable name called name, and whatever is there in this function is executed. At the end of it, my control comes back to this line itself. This is how function calls work. Again, when you're running function calls, what's happening? This code is in your computer. This calling function, this whole calling code is in your computer. This called function is also in your computer very often. Okay, so all of them are in the same computer, right? Of course, this function could be in a different folder or in a different library. That's all okay. But both this and this are on the same computer. Okay, that's the important part. Typical function calls in Python. Okay, you can think of API as also a fancier version of a function call. That's it. What is a web API? So again, there are many types of APIs. Web APIs are the most popular and most widely used. So how does a web API work? Okay, let's understand that step by step. Let me change the colors a little. Okay, let me use this color. Okay, suppose imagine if this is a code that I have. Okay, so this line is executed. I'm calling this function f. Now when I call this function f, what happens? The control goes here. This Srikanth is copied to the name variable. And then again, there is some body of the function, right? Where I execute this, I execute this, I execute this. So in a web API, what happens is this. This is very interesting. In a web API, you want to run, again, to complete this. So there is a chunk of code here. Okay, through which you want to call. Again, remember that this function, this code snippet and this are on the same box. So let me draw a bounding box here. Okay, so these two are on the same computer. This is your local computer, let's say. Okay, this whole thing is on your local computer. Now this function will make a request. Okay, it will make a request to a web server. Okay, this web server could be located anywhere on the internet. Remember, this is your desktop. This is any web server. It could be a Google server, it could be an Amazon server, it could be an Azure server, doesn't matter. Okay, the way it works is this function, let's call this function as f API. Okay, this is a web API. This is how web API works. So this function f now makes a request. So this works using a request response type of system. And this request is sent using HTTP protocol typically. What is HTTP? HTTP is a protocol that is used to access web pages. Okay, if you go to any web page, you see http://facebook.com. So HTTP is the web-based protocol for looking up at web pages. Now the same HTTP protocol is used to call a function on a web server. This function is sitting on a web server. So I request, when I make a request, I can also send some parameters. Some parameters to this function. These parameters will go into this function. This whole function will execute. Whatever is the output of this function comes back to the calling code. Now remember, this request is sent via the internet using HTTP. Again, HTTP is the most popular. You can do it with other protocols also. These are typically called as web APIs because you're using a web-based protocol. You're requesting. See, in a web-based protocol, what do? Typically in HTTP, you request for a page and the server sends you a page. Here, what are you doing? You're sending a request to execute this function with some parameters of your choice or some arguments of your choice. And this sends back a response. This response is typically sent back using formats like JSON, XML, etc. Again, JSON being one of the most popular ones. Okay, there is also XML. Again, in our Python videos, in our course, we have discussed about JSON, XML, etc. Right? So this is the basics of how web APIs themselves work. Again, we have done an earlier live session where we discussed about how to build a web API yourself using Flask. And how to deploy it on AWS. This is the live session that we have done earlier, right? So in this live session, we are not going to discuss how to build a web API. We are going to learn how to use a web API. Now in this whole system, there is also one more layer called security. Now what is security? Security basically, when I'm making a request to the web server, think about it, when I go and request for a web page, I could send my username, password, credentials to log into a web page. Right? Similarly, for web APIs, okay, there is something called as an API key. Okay, so there is something called as API keys that you send along with your request. Along with your request, you send API key to tell exactly who you are, because some of these APIs will charge you. There is a chargeable amount for every function call that you make, because this is again, where is this function FAPI running? It's running on the web server. Imagine if it's running on the Google server, Google is spending money to execute that function for you, right? So Google could charge a small amount. Just to ensure that you're the person whom it should be charged, there are some API keys. So API keys are used mostly for security and billing purposes, right? I hope this picture is clear. Again, we'll see this example, we'll see this actually working in practice. Okay, so let's go step by step. This is the big idea behind web APIs themselves. Now let's dive into Google speech to text. Okay, so the most important thing that you have to remember or learn is this whole system that, okay, so let me show you this. The most important thing here is this. This is your calling function. This is this calling this function. This function will call a function sitting on a web server. Again, some of you who might have studied Java, etc., might have learned about remote procedure calls, RPCs, right? Again, this is something that I remember learning in my B.Tech. Remote procedure calls were a popular technology, especially in Java. You can do it even today, but web APIs you can think of as the next generation of RPCs or remote procedure calls, because you are calling a function that is there remotely on a web server using web-based protocols and request responses using JSON, XML, and all these are data formats that are very extensively used on the internet, right? So there are only three pieces. There is a request, there is a response, and there are API keys. These are the three things that you should know, right? It's as simple as that. Okay, so let's go down. Okay, again, I'll go step by step, and in between I'll go to the chat window and try to answer a few questions if there are any. But let me go through each of these step by step first. Okay, so let's go Google speech to text, right? So before we go in, again, you can read a lot about Google speech to text in this link. I'll share this document with you at the end of the live session, but just bear with me. This is where, again, you can read a lot about how Google speech to text itself helps you. This is a web API that is provided by Google Cloud, right? Now, a big question that many of you might have is, why not build my own speech to text using advanced speech to text algorithms like transformer models or attention models, etc. A very common question that we encounter. Why don't we simply use our own speech to text, right? So just let me go into the comment section and see if everything is all right. Okay, sounds good. Yeah, I think everything is okay. So let me go back to the document itself. Okay, so the question here is, why not build our own speech to text using a transformer model or attention model? One of the biggest problems in building your own speech to text is data. There are multiple parts. Imagine a company like Google, which owns Android, okay, which owns Google Assistant. They are sitting on literally a gold mine of data. Okay, they listen to people. They have data of audio from people almost from everywhere in the world, different accents, different speaking rates, right? So they are sitting literally in a gold mine of data, and they have the resources to, so they have labeled data, they have raw data, and they have high quality labeled data. Imagine a company like Google, because speech to text is such an important part of the technology stack, whether it's on Android, whether it's on Google Assistant, whatever it is, they can spend a few $1 million going through thousands and thousands of sentences that people have spoken and get them labeled manually for correctness. So this sort of high quality labeled data, you and I, normal beings, may not have access to. Number two. Number three that they have is compute resources. Google can train and experiment with fabulously complex models. Okay, so because they have like literally tens of thousands of computers, GPU computers at their disposal for their research work, even for their production work, right? So what Google can give us in terms of what Google has in terms of compute is enormous. Fourth thing they have is people. Google has some of the best concentration of deep learning researchers in the world, whether it's at Google DeepMind or Google Brain or Google product teams, etc., right? So Google has great data, it has enormous amounts of labeled data, it has compute resources and people, that if we try to build our own speech to text, it will be very hard to compete with what Google can build because of these fundamental advantages that a company like Google has. Again, just like Google, there is also an Azure speech to text, there is also an IBM speech to text, there is also AWS. AWS is again owned by Amazon, it stands for Amazon Web Services. Each of these services has a speech to text API that you can call. But amongst all of them, Google seems to be one of the best, especially when I try with my Indian accent. Okay, I'm sure others also work very well for other accents, but I've seen Google to work the best for Indian accent or even for accents across the world, right? So the reason to use a speech to text like Google is, again, the fourth, again, because they have these huge advantages, and most importantly, if they already have it and if they're making it available through an API, why not just reuse it? Why not just reuse it? For example, look at this. In your Python, right? So a very common example that I give people is in Python, we have dictionaries, right? Which is nothing but a hash table. Which is nothing but a hash table, right? A dictionary is nothing but a hash table. Hash table is a very, very popular data structure in computer science. How many of us implement hash tables whenever we need to? We don't. We use a dictionary in Python because it implements the hash table. I know, again, remember that as a good software engineer, I should know how a hash table works. I should know how the internals of a hash table. But I don't have to implement hash table every time because the designers of Python have done it using a data structure called dict, which is nothing but a hash table, right? But as a good software engineer, I should know the internals. Similarly, when I'm using a speech to text system, I should know how well it works, and it's always a good practice if you want to do it quickly. It's always good to use Google speech to text as your first cut solution. Right? Of course, you can build your own system using transformers, but very likely, unless you are working in a very specific domain and unless you have large training data, your results may not be as comparable to Google speech to text. Right? It's fairly hard to beat that. I mean, it's not impossible. I've seen in specific applications, for example, if you want medical, I've seen a few medical companies. What they do is this. Medical terminology is very different from the terminology that Google sees as part of their data set. So there are companies that collect a lot of medical data, what the doctor says, the medicines that the doctor is prescribing, and they just listen to it. They get a lot of high quality labeled data and they train their model only on medical data, which means their models, their transformers or attention models are going to perform phenomenally well on medical data, while Google may not be able to. So unless you have very specific applications where Google is not performing well, it makes complete sense to use Google speech to text. Of course, there is a small cost associated with it, but let's go through Google's cloud speech to text, right? So let's just go there. I'll just show you how it looks. Okay, so just go to that link. What you see is this. Okay, you see a speech to text here. It says speech to text conversion powered by machine learning. There is a ton of documentation that you can read. The best part is this. You can upload a small audio file and it will give you, again, you can try how well this works actually. You can just choose a file, upload this file, and it will give you the output. of whatever audio is there in the, it will give you speech to text output, right? Very, very interesting, right? So again, Google can recognize 120 languages, variants, all of that stuff, right? I mean, phenomenally, I mean, they've designed it phenomenally well. And Google can detect if you're giving a command. Like for example, a command like set an alarm. I give this command to my Google Assistant every now and then. Or if you have phone calls, right? Google has trained a special model for phone calls. Even if you give it a video, it can transcribe or convert the speech to text of the audio in the video. Then there is a default system which works for long form audio. If you have, let's say, 5 minutes of audio and you want to convert that to text, this is very good, right? Again, there are multiple features, advantages, all of that stuff. There are things like speaker diarization, which basically says, which detects the speaker who is speaking a specific sentence. Imagine if there is an audio snippet with multiple speakers. It can recognize which speaker said what. Of course, there is a price associated with it. Again, because Google is spending, I mean, tons of resources on it. For some, like up to 60 minutes of audio, this service is free. Beyond that, they'll charge a small amount. Okay, so again, this is important to note. Okay, there is a bunch of documentation, but instead of going to the documentation, let me show you. First and foremost, you should go to Google Cloud. Okay, let me just go there. Just go to cloud.google.com, sign up. Again, we have an account because we use Google services for some of our work. Just sign up. Okay, this is again our account, right? This is our account which we use. But please sign up on cloud.google.com. When you are signing up, it will mostly ask for your credit card, right? So just sign up for a Google account, just like the way you sign up for a Gmail account or anything. Just sign up for a cloud.google.com account, but it asks for a valid credit card to create an account. This is mandatory. Without this, it will not let you create an account. Okay, so please make sure that you have a valid credit card. Unfortunately, they force you to do it because in case you use the service a lot, they have to charge you to your credit card. Number one. Then go to this web page. Okay, so once you've created the account, just go to console.cloud.google.com. Again, it says go to console, right? You can just go to console there. Again, just like Google speech to text, there are many other services. So Google has something called as cloud.google.com/vision. Okay, in this, Google can do or detect objects automatically, understand text in images, right? All of this it can do. Just like the way we are doing speech to text, I'm showing you one API. There are hundreds of APIs on Google Cloud, right? You can also do it for images also. Just wanted to tell you that. I'll show you speech to text, but similar things you can do it for understanding text in an image, detecting objects, all sorts of stuff. The concepts stay the same, right? The concept of calling the API stays the same. It's just that you have to call a different API. That's it. It's like calling a different function altogether. Okay, so then just go to console. If you go to console, this is how it looks like. This is our console page. Okay, so once you go to console page, I've created screenshots so that you can use this. First and foremost, create an account and go to console.cloud.google.com. I'm trying to take you step by step. Next, first we have to create an API key, right? Because API key tells, without an API key, you can't call Google Web API. So what you have to do, you go to this web page, go to this, again, I've taken screenshots so that you can reuse this. You can take these slides and follow the same steps. Okay, console.cloud.google.com, just go here. To get the API key, on the left side, you have APIs and services. Let me also show you this, APIs and services. In APIs and services, go to credentials. Okay, that's what, again, I have highlighted that here clearly. Go to APIs and services, click on credentials, right? Again, what are we doing here? We are trying to get an API key for ourselves to call the function. We need the API key. Without this, we can't get it to work. Okay, so first create your Google Cloud account, then let's get the API key. Click on credentials. Once you go to credentials, create credentials. Click on create credentials. It will show you service account. Click on this. I'm giving you step-by-step instructions here. Once you go to service account, okay, you can fill this form. Okay, you can just call whatever name you want. We are calling it AAC live because we are using these keys for live session only. Okay, it will give you some account name, all of that stuff, and I can describe what I want to do to explain the concept of API speech to text. Just fill this form. and click create. Okay. Now once you click create, it also says, do you want some account permissions, owner permissions, etc. Just if you don't need this, don't worry about it. This is optional. Just click on continue. Okay. When you click on continue, it will give you this page and just click on create key. Again, I'm giving you step by step here. Okay. Click on create key here. Once you click on that, it says, how do you want to create your key? Do you want it in JSON format or P12 format? JSON is the recommended one. So just click on JSON, choose this option JSON and click on create. Okay. So the moment you do this, this is what you get. It says, I have created this JSON file. It's called niffy buffer blah 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 .json and it is downloaded to my computer. Okay. So now what do you have? You have the JSON key or you have the API key to call the remote function or the web API. Okay. So just download this. Now what I do now is I rename this. Okay. Because this name is so cumbersome. I just renamed this JSON file. Okay. You know how to rename it, right? You downloaded it to your folder on your computer. Just rename this to api-key.json. And if you go into that, this is how it looks. Again, I have cleared out all my URLs because this is specific to our company, right? But if you see, if you just open the JSON file, this is how it looks. So whatever JSON file I downloaded from for my API keys, which is niffy buffer blah blah blah, I changed it to api-key.json, and when you open it, it looks like this. Right? Cool. Okay. Now let's go to Google Colab and run the whole thing now. Cool. This is simple, right? So what have we done now? We have done two things. We have first created an account on Google Cloud, and we have downloaded the API key as JSON file, and we called that API key JSON file as api-key.json. Now let's go to Google Colab file. Okay, so let me walk you through Google Colab now. Okay, so this is my Google Colab file. Let me just zoom this in a little so that you can see what's happening. Okay, I'm zooming it in so that you can see the code. Now, what is Google Colab? Again, those of you who already know IPython notebooks, Google Colab is like running an IPython notebook on the Google Cloud from your Google Drive itself. Right? Very simple. Again, this is one of the simplest ways if you don't want to go through the headaches of installing Python, IPython notebook, Jupyter notebooks, all of that headache. This is one of the easiest ways to do it. First and foremost, so let me go code line by line. So first what I do, from google.colab import drive. Okay, so why is this needed? Because this is, again, how does it work on your typical computer? Okay, you have your IPython notebook here and you have your whole disk here. You have your whole hard disk here, right? This is your IPython notebook. On your IPython notebook, you can access all the folders on your disk. This is how it typically works, right? And all of this is on your same computer, right? Now what happens is, this IPython notebook wants to access your Google Drive. So when you say import to drive, what do you want to do? You want to now mount this drive or access this drive, right? So the first step, this line basically says, from Google Colab import to drive. Why do we need this? Because we want to use Google Drive as a disk, as a hard disk. Now first step. Second step is you mount your Google Drive. Mounting basically means, again, mounting is a term that comes from Unix and Linux terminology. It basically means make your Google Drive accessible from this IPython notebook or from this Colab notebook, right? Very simple command, drive.mount. Just say content G drive. This is fixed. So what this does is it makes your whole Google Drive accessible to this IPython notebook, right? So just like your disk is accessible by default to your IPython notebook, now your Colab notebook can access your whole Google Drive. It can access your whole Google Drive. So that I'll use Google Drive as my hard disk now, right? That's very, very important, right? So I have this. So when you mount it, it says it requires authorization code because it wants to ensure that you are using your Google Drive itself. So the moment you execute this, it says, click on this link. When you click on this link, it will give you a code. It will give you a big hexadecimal, it will give you a big alphanumeric code. Just press it here and press enter. It will say mounted Google Drive, right? So now what have we done in these two steps? In these two steps, we have made sure that we are going to use Google Drive as the disk in which we will store and retrieve stuff. First and foremost. So what I have done here for this session, what I have done is this. I've created in my Google Drive, look at this. So content, G Drive, my drive. This is my whole Google Drive. Within my Google Drive, let me show you this so that you are, okay. So let me show you this. So in my drive, this is my company's Google Drive, right? In Google Drive, I have a folder called live sessions. This is the date on which we created some of this data, 24th Feb, and we call it speech to text. Okay, in this speech to text folder, I have all the files that I need for the next steps. So what am I doing here? Look at this. When you run a line like this, look at this, in IPython notebooks or even in Colab, you can run Linux commands like this. %cd. CD basically means change directory in Unix. What am I saying? I'm saying change to this directory. Right now, what directory it is in? It is in content G drive. It is in this directory now. So what am I saying? Please change it to content G drive, my drive. So first of all, what you should do is you should create a folder called speech to text on your own drive, whichever folder you want. You can create it within your whole drive itself. Mount that. Okay, so you change it. See, you already mounted your whole drive. You change the directory. Then this exclamation ls basically means list all the contents of this folder. Again, these are commands that you encounter on Linux or Unix or Mac, right? Because at the end of the day, Google runs all of this on Linux clusters, right? So when you say ls, what happens? It will print all the contents of this folder. In my speech to text folder, I have some PNGs. Just ignore these PNGs. These PNGs are nothing but the screenshots that I have shown you earlier. The most important ones are these: API key.json. Remember, the API key that I downloaded from Google, I uploaded to my Google Drive in this folder. So whatever is your JSON key, remember just a while ago I showed you that I downloaded API key.json from my Google account. I uploaded it to speech to text in my Google Drive. Okay, I also uploaded another audio file. This audio file is genevv.wav. Okay, this is an audio file that I want to convert to text. I also created a folder called parts. Okay, I'll tell you why we created the parts. Then again, you don't have to worry about IPython checkpoints because it's automatically created for you. Then there is requirements.txt. These are the 4 important files that you need. Again, you will have your own API key.json. We'll share the geneview.wav file. We'll also share the requirements file. I'll tell you why each of these are required in a little while. So what have I done now? I've changed my directory to this directory now. In this directory, these are the 4 files and folders that I will use. Okay. First and foremost, before I go ahead, I want to tell you, first we have to set up the environment, right? All the other libraries that we need to first install them, right? Because this Google Colab may not have all the libraries that we need. So the requirements.txt file, if you just cat, !cat, what does cat do in Linux? Cat basically prints the contents of a file. So the requirements.txt file has all the libraries that we need to install to make this whole code work. Very simple. Okay, so this is the list of all the files, all the packages that you need or libraries that you need to execute this. Okay, so that's what is there in your requirements.txt. Next, look at this line. Next line is very important. It says exclamation pip. What does pip do? Pip is Python installer. Right? Pip, basically you can install Python packages using pip. Pip install -r requirements.txt. Now what does this do? Whatever is there, whatever libraries are there in requirements.txt, it will try to install all of them. Right? Pip install basically installs all these libraries that we need for the rest of the whole system. The most interesting library here is speech recognition. I'll tell you why. Again, this is the name of the library or the package, and this is the version. I'm also giving the version. If this version number does not exist, it will simply force it and install this. So look at this. It's downloading all of them, installing it to your Colab now. Very good. So what have we done now? We have moved again, this is very important. You need to create a folder in your Google Drive, copy the API key that you got, whatever is the audio file that you want to transcribe or convert to text, the requirements file and the parts folder. Okay, what have we done till now? We have installed all the requirements that we need to execute rest of the code, all the libraries that we need. Okay, next, let's look at the audio file itself. This audio file is called gene, look at this audio file, this is the name of the audio file. If you look at the audio file, again, we can listen to the audio file also. What I'm trying to do with this FFmpeg line, look at this FFmpeg line basically says, again, FFmpeg is a very popular Linux tool to cut audio and video the way we want, to process audio and video. So exclamation FFmpeg -i, which means this is my input. Remember, this is my input file. Now what I want to do here is I want to segment this input file into 30-second chunks. See, this is my whole file. Okay, this is my whole audio file. I think this is close to 90 seconds if I'm not wrong. Okay, this is a 90-second audio file. I'm breaking it into 30-second files. I'll tell you why I'm doing it little later. Just bear with me. Okay, so this command basically, again, you can just Google search for this command and you'll get it. I don't remember it by heart, to be honest with you. I Google searched. Again, I think my teammates actually Google searched to create this document. Right, so FFmpeg -i, this is my input file. I'm going to break it into 30-second chunks and I'm going to copy all of those 30-second chunks into this folder. So now my parts file, my parts folder has out.wav. Now look at this. What am I doing with this? I'm taking this bigger audio file. This is my input. I'm chunking it, or I'm segmenting it into 30-second audio snippets. And these 30-second audio snippets, I'm storing it into, or I'm copying them into the parts folder without some numbering. Now, if I now let's go to this parts folder and list what all files are there. Look at this. Okay, so I'll come there in a while. Okay, so that's what I have done. Actually, there is a line here. Let me show you. Do we have it here? Yeah. So okay, so it created 3 files actually. Parts, out, all zeros, out 1, 2. So this %0, some of you may be concerned about this syntax here. This %09 out %09d wav. What this means is the first file, make it as out followed by 9 zeros. 4, 5, 6, 4, 4.wav. This will be my first file. My second file will be out. The 9 basically means 9 zeros. Okay, the second one will be 00001.wav. The third one will be out 00002.wav, etc. You can use any number here. That's okay. So what have we done here? We have taken the big 90-second, roughly about 90-second audio file, and we have broken it up into 30-second audio chunks. Now, why we are doing it, I'll come to it in a little while. You don't have to do it always. Okay, but there is a reason why I have done it. I'll show you in a little while. Just bear with me. Okay, now let's go to the core of it. Now we have our input data, we have our keys, we have installed all the requirements. So let's go down and actually run the code. So there is this package called as speech recognition. Okay, very interesting package. So if you, this is the reference link, you can just go here. This speech recognition library, again here we are using another library called speech recognition, very popular library, through which you can call Google Cloud Speech API, you can call Azure Speech API, you can call Bing Voice Recognition, right? You can also call IBM Speech to Text. So this is one library, again this is one library or package that you have, speech recognition package, with which you can call most of the major speech to text recognizer systems. Again, CMU Sphinx is an slightly old model which you can run on your own computer. This is not a web API based system. Okay, this was built at Carnegie Mellon University. It's a very popular technology before cutting edge stuff that Google and Azure and AWS are building now. But this has existed for a very long time. So the speech recognition package here, that a library that we have here, can help us call Google Cloud Speech API, Azure Speech API, or Bing recognition, whatever we want. That's the best part about this. Now, of course, there's a lot of documentation about this, but let's dive into the code itself. So what am I doing here? I'm just importing speech recognition as SR. Very simple. And if I just see SR is a module, blah, 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 all that stuff is there. Cool, no problem. Right? Now look at this. Okay. So I'm writing some code here for something called as multiprocessing. So import OS, we all know what OS is, right? Then these lines basically are for something called as multiprocessing. I'll explain you multiprocessing in a little while. Okay. Suppose in multiprocessing, what happens is this. Typically, what do we do? I think some of you may know about multi-threading and things like that. So what it does here is, imagine if I have a lot of audio files, right? I have audio out 0000.wav file. I have out 00001.wav file, right? I have out 002.wav file. Imagine if I have lots of WAV files like this. If I want to call the Google speech to text API parallelly with this audio, with this audio, with this audio. See, one thing that I can do is I can first get the speech to text for this, then speech to text for this, then speech to text for this, then speech to text, so on and so forth. But that could be time taking, right? So what is an alternative? An alternative is, can I call all of them parallelly using different threads? That's what multiprocessing is all about. I wanted to show you that also. Okay, remember the reason we created from our big file, from our 90-second audio file, we created 3 30-second audio files because I wanted to show you how to call all these three, how to get transcription for speech to text for all three parallelly also. For that, we will use this whole concept called as pooling. Okay, so this is, again, those of you who have studied Python in more depth, you would know about multi-threading and multiprocessing, etc. It's a fairly simple concept. Basically multiple, because most likely you have a multi-core computer with multiple threads, all of them can run parallelly. Okay, so let's keep this here. This is primarily to be able to do multi-threading or multiprocessing. Okay, so let's go back again. Now look at this. Okay, so first and foremost, I want to read my API key. Right, I want to read my API key. So what does this line say? This line says, okay, with open, I want to open this file as F, and I want to read this file. Whatever are the contents of this file, I want to store it in a variable called Google Cloud Speech Credentials, all in caps. Okay, so this is my whole, so this variable now contains all the contents of my API key. Right. So what have I done here? Again, I can't show you all of my, I can't show you my API key, because if everybody uses it, I'm going to get charged like crazy. So I'm just showing you a part of it. Okay. I'm just showing you a small part of my API key, but you'll get this, you'll get something like this. Basically what you're doing here is, you're loading your API key JSON contents into this variable called Google Cloud Speech Credentials. And I'm just printing that to see everything is all right. Now comes the core part of it. Now what am I doing? I have my speech, see, look at this, my whole library, where is this? Okay, my whole speech recognition library, I have loaded it as SR. Now I want to create a speech recognizer, right? So I create a variable called R, or an object called R, sr.recognizer. So this is my speech recognizer object. Okay, cool, very simple. Now look at this, I want to see what all files are there in the parts folder. Okay, this is very simple. I'm using os.list directory function, and I'm saying within the parts what all files are there. Whatever files are there, list them. And I'm using os.list directory and sort them. So these are the 3 files that I have in my parts folder. Right, now let's look at this. Now what do I want to do? I want to convert, let's take this one. Okay, let's take this. I want to take this 30-second audio and I want to convert it into text. That's what I want to do, right? So before we go there, let's listen to it. In IPython notebook, you can listen to audio also. Okay, so all you have to do here is, again, I'm creating a file name, parts plus file 0, which basically means parts /out90s.wav. This is my file name. Okay, so you can actually listen to an audio file also. You just have to say ipython.display import audio, and you say audio file name. If you click on this will play actually. This will actually play. Let me see if I can, I don't know if you can hear this.
This dynamic workshop.
Yeah, you can actually play this. You can listen to this 30-second audio. Again, I want to, I'll share this whole document with you so that you can try it on your own Google Drive accounts. Okay, now this is cool. So I have my audio file. I have my audio file name. Now I have my recognizer object. I just have to call the remote function now. Okay, so let's go into this. So first and foremost, I have the file name. This name corresponds to my file name, my out000.wav. First, I want to load the audio which is there. So what do? I just say with sr.audio file name as source, just record. So this audio object now, look at this, this audio variable now contains the actual audio that is there in this file name, right? first and foremost, right? So from a file name, I've loaded the audio into this variable called audio, right? By just using this function or this snippet of code. Now we want to transcribe it, which basically means I want to get the text for it. Getting the text is literally this line of code. So text equals to R. Again, this is my recognizer object, R dot recognize using Google Cloud. Look at this. What does this function do now? This function says, okay, where do I have to go to? I have to go to Google Cloud. What is the audio that I want? This is the audio that I want to transcribe or get the text for it. What are my credentials? All my credentials are there in the Google Cloud speech credentials variable. That's it. This single function. What this function does now? It goes to Google's cloud. It goes to Google's cloud. When it goes to Google's cloud, it sends the audio in the request. Remember, in the request, it sends the audio. It also sends my API key credentials. It also sends my API and audio. In the request, it sends my API and audio to the Google Cloud servers. Google Cloud server sends back. What does it send back? It sends back this text to me. And if I just print the text is actually like this. This dynamic workshop aims to provide up-to-date information. Again, I'll share this. So it is giving you the text output for it, for the audio. It has given you the text output. Okay, let me do one thing. Let me just help you hear this. Just give me a second. Let me help you hear this. I'm increasing the volume on my computer, coming close.
This dynamic workshop aims to provide up-to-date information on pharmacology.
Okay, I hope you could hear the audio slightly. Again, I'll share these documents with you. You can try this. It clearly says this dynamic workshop aims to provide up-to-date information of pharmacological approaches, blah, 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 blah. So this single line here, if you notice, so this single line was where all the magic was happening. What we have done till now is the miscellaneous stuff around it, right? Very simple. Now I can put all of this into one single function. Look at what I'm writing here. This function is called transcribe. Look at what I'm doing here. This function is called transcribe. In the data part, again, I'm trying to put everything that we have discussed now into one function. I'll call this function as transcribe. This data is nothing but the file name. This data here is nothing but the file name. So using this file name that I have, I'm constructing the actual file name by concatenating with the parts folder, as we have just seen. Okay, next, what are we doing here? Next, look at this, loading the audio file. This, we have seen these lines, right? Whatever lines we have seen, I'm just trying to put them into one function now. Then I can call the function and I can print the whole thing. Look at this. This is loading the audio. Whatever data was there in this file name in the parts folder, I'm loading it into an audio object, right? Or an audio variable, and I'm just calling recognize Google Cloud with this audio as input with my credentials which are stored here. That's it. And the whole output from Google Cloud, I'm going to store it in text and I'm going to print it. So as a programmer, you don't see much of a difference between calling a function, calling a web API function and calling a local function. Only that you need to be connected to the internet. If you're not connected to the internet, this whole thing will not work. That's the key. Because this function, you have to go via the internet using internet protocols, send both the audio and the credentials and get the data back. Except that from a code perspective, this all feels like just calling a function. It's that simple. Now, given that I have transcribed function, let me show you how we can actually do multiprocessing or parallel processing if you want to think about it. Imagine if I have multiple files that I have. Imagine if I have out 0000.wav, 1.wav. Suppose if I have 100 files like this. I wanted to show you this because in the real world you may have many files like this and you want to do this fast. So you want to call this function, look at this, you want to call this function transcribe, right, with this file name as an input, and while that is still getting the text, you want to call this parallelly, you want to call this parallelly, you want to call this parallelly, you want to do all of that. All of that can be done using pool. Again, I told you about multi-threading, right? So pool.map, so this function does that. Pool.map, you are saying which function to call and what are the inputs to each of these function calls, right? That's it. It's a very simple thing. You're saying pool.map, right? You're saying call the transcribe function right? Using whatever you have in the files variable. Again, files contains a bunch of file names. Okay, just give that as input to each of the transcribed function calls and then close your pool and then join. This basically what it basically does internally is very simple. What it basically does is it calls all these functions and all the output goes into this variable called alt text. Now if you just print alt text, what do you get? You get okay. Because how did we write the return here? We get the ID and the text, right? So you get ID as 0, text. This is the whole text of the first file. ID 1, text. ID 2, text. So this way, by using the pool and the map, by using this multi-threading or multi-processing concept called pool that I just showed you a while ago. Where is this? Where was that? I showed you a while ago, right? Let me go up. Yeah. So using this sort of construct called pool and using this line, you can call, and using these three lines, you can call the transcribe function with multiple inputs parallelly, right? So this is how you call the Google API with one audio file at a time and using multiple audio files parallelly, both, right? So this is one part. I hope this is clear. Again, you will have to play with this, try it, and my recommendation, again, right after this live session, I'll edit this and I'll upload all of these documents, all of these Google Colab files, etc. Give me a couple of hours after the live session because I'll have to remove some of our API keys, etc. and share it with you. Right? Simple. Okay. So this is one. Let me go to the chat window and see where we are. Okay. Yeah, somebody is asking about FFmpeg. Yeah, FFmpeg has lots of documentation. I've been using it for the last for 15 years now, and I don't remember it by heart. Every time I need, I just go Google search FFmpeg how to cut an audio file. I don't remember the documentation by heart, but there are tons of resources online. To be honest with you, I don't remember the document. Again, I don't remember documentation of most libraries. Whenever I need it, I go read the documentation and use it. Because it's almost impossible for anyone to remember like hundreds of major libraries. Even matplotlib type stuff, we can't do it. So where will you share files? Okay, so what I'll do here is in the comment section, the first comment, I'll pin it. I'll provide you the links to the audio file, the requirements file, and the Colab notebooks. Just give me a couple of hours after this live because I need to sanitize it, remove our API keys, etc. and share it with you. I'll put it just right under this live session itself. Okay, just under the live session itself, as the first comment, I'll post all the links. Okay. Oh yes, somebody says, can you do it for other languages apart from English? I have tried it for other languages like Telugu, which is my mother tongue, which I can speak fairly fluently, but it works okay-ish. Google claims that they can do it in 120 languages. I'm sure they can do it for some of the European languages very well because they're so extensively used. In countries like India, where English is still very popular, when we communicate with Google, I think some of the Indian languages are not very good. I heard Hindi is pretty decent. I haven't tried it myself. While chunking, it could corrupt some words. That's okay. There might be some error at the very end or at the very beginning. Some small chunking might happen at the very end, but that's okay. I mean, again, the only reason I chunked this bigger 90-second file into smaller files is to show you how multi-processing or multi-threading happens. Okay, because in your real world, you might have like some 30 files that you want to call these functions on, and instead of calling one after the other, you could just pool everything together and send it so that you get results faster, right? Sounds good. So let's take a couple of minutes break. I just need to sip some water and then we'll go to the Bing one. Okay, that's easier. Bing makes it. So again, somebody says, does it work good for Hindi? I've heard it works good for at least the proper Hindi accent, the typical. Again, there are so many accents of Hindi itself. There is a South Indian Hindi accent. There is a Hyderabadi Hindi accent, right? There is a Lucknowi accent, which is slightly different. But I think if you speak regular TV news type Hindi, I think it will work fairly well, right? TV news type Hindi is the most generic one. So sounds good. Let's jump into, okay, so in the interest of time, because we have only one more hour, so this is how Google works. Again, let's go to, I have another one. Okay, so let me go to my notes. Okay, so this is done. Okay, let's go to Bing Search API. Now, this has been one of my favorite APIs. I've used this extensively and multiple times. Again, you might ask me, why are you using Bing Search API? Why not Google Search API? Two reasons. Because Google does not give you a search API. Google doesn't want to give anything related to their search, right? So, but Bing and Azure or Microsoft in general gives you a search API. That's why I'm using it, number one. Number two is, of all the machine learning tools or machine learning APIs that you have, some of the best ones I found on Google, to be honest. Again, I try to be as unbiased as possible. So Google is one of the best web APIs for machine learning that I've seen. Second is Azure. Third is AWS. IBM, I think, comes last. Again, from my own experience. And I've used these APIs to, especially for speech to text, for natural language understanding. I've tried all of them. Google typically tends to outperform most of them. And Google and Azure almost perform very close. Like for example, AWS speech to text is not as good. Again, I think the reason Google and Azure perform very well is because both of them have search engines. Right? So both of them have search engines, which makes their life, they're literally sitting on a gold mine of data. Right? AWS with its Alexa has done some good work, but again, I've come across so many instances where an Alexa cannot recognize my Indian accent, but Google can recognize with the Google Assistant. Right? I've seen this in practice. I've seen this extensively. IBM, I think IBM does a lot of marketing and stuff, but in terms of pure quality of outputs, I would pick Google or Azure any day over IBM. I mean, again, I could be biased. There might be few things in which IBM might be doing better, but in my own experience that I've used, Google and Azure are almost the best. They're very close to each other. Google has a small little edge, primarily probably because of Android data and because of Chrome data, right? So first and foremost, so Bing calls, or Azure calls their whole thing called as cognitive services, right? I've seen a lot of startups use this, and I mean, Azure is also very, very fast growing cloud provider, doing a very good job here, right? Again, just to be fair here, I prefer AWS over Azure and other things when it comes to distributed system platforms. The whole cloud computing itself, I prefer AWS over Azure. But when it comes to Azure or Google Compute Platform, but when it comes to machine learning itself, I prefer Azure and Google Compute Platform over AWS. And I think these things are constantly changing. Today, whatever I'm picking, whichever sides I'm picking, tomorrow things might change if AWS invests more money there and more resources. Anyway, back to our topic. So AWS calls this as cognitive services. If you just go to this link, again, the sign up process is very simple. The good thing with Azure is they'll give you a couple of keys. There is no JSON file. They'll give you simple keys that are valid for 7 days. You don't require a credit card to use it. For 7 days, you don't require a credit card to use it. After 7 days, you have to enter your credit card credentials, right? So for 7 days, they'll give you a couple of keys. You can use them to access their APIs free of cost. Of course, there are some limits and constraints, but you don't require a credit card. So those of you who may not have a credit card, like students, and who could not get it for whatever reason, feel free to use Azure APIs, because Google forces you to give a credit card. Again, their sign up process is very, very simple. Let me show you. This is Google Azure Cognitive Services. Again, if you just go through this link that I've shown you, if you just click on this link, it will take you to this page. Here you have Bing Search API version 7. Again, look at what all searches you can do. You can do web search, you can do image search, you can do video search, you can do news search, you can do visual search. Similarly, Bing spell check. Look at how well the search engines do spell check. You can do a spell check, right? You can do Bing auto suggest, right? Or you can even do entity search on Google's knowledge graph. So whatever you want. So in our case, we're going to use Google Bing search. Just click on get API key, you'll get API key. It's that simple. Just log in, very simple login form. They'll give you a couple of keys. Now in this example, I'll do slightly different from what I've done for the Google API. In Google API, we use the speech recognition package, right? In that, we use the speech recognition package, which did all of the calling, all of that stuff for us. In this example, for Bing search, we will implement the API calling from scratch using core Python only. We will not use any libraries. Again, there are libraries to use Bing search APIs also. But again, if you recall, when we used Google Compute Platform speech to text, what did we use? We loaded this library called speech recognition, which could call all of them without us having to worry about it. It was like loading a package, making a function call. In this example, we'll do something slightly different. What we'll do now is, we will write the code for API calling from scratch using core Python libraries. Okay, I want to show you how you can implement it yourself. You don't have to always depend on a library like speech recognition, right? So just wanted to show you that. Okay, so let's go into this. Okay, so this is the code might be slightly longer than previous one, but I'll go step by step. That's okay. It's disconnected, but that's okay, not a problem. Again, I'm sharing my codes. Please don't use my codes. Sorry. Okay, so please don't use my keys here. Okay, let's go step by step. Just like in the previous case, from Google Colab, import drive. I'm just going to load Google Drive if I need to. Again, I've just written the steps here, right? Very simple. To be very clear, all this work is not just my work. It's a work done by my whole team, tons of people. I think this was done by a couple of our very good machine learning engineers who collected the data, who wrote all this code, comments, all of that stuff. I'm just the presenter. Please understand that. I'm just a conduit to share the knowledge. That's it. I think I've done just maybe a couple of edits to this code, but most of it was done by my team. Anyway, so these are the steps. So once you go to this, once you get your keys, you get a couple of keys, right? So these are the keys that we got. Again, this is free for 7 days, but after that, again, please don't use our keys because they'll throttle and stop us. You please generate your own keys. Okay, so that you can, again, remember, if you use our keys, if everybody uses our keys, what happens is our account will get blocked. Nobody can use it. So please get your own API keys. API key looks like an alphanumeric thing here, not a JSON file like in Google, right? We got a couple of keys. Okay, now what are we doing here? Simple. First, we will load this Bing search v7 subscription key. We are creating this variable and we are saying input subscription key. What does this do? It will ask me to input it. So I'm just giving this as the input. So this variable Bing search v7 subscription key will contain this key value now. Again, I'm repeating it. Please don't use our keys. Create your own keys and use it so that you can try more stuff. And for every different service, you have to get a different key. These keys are only for Bing web search API version 7. Okay, so simple. Okay, now let's go and use this. So let's go step by step. I'm importing operating system package. In this, what am I doing here? In my operating system, I'm creating an environment called Bing search v7 subscription key. This is basically creating an environment variable in my operating system. That's it. And for this environment variable, I'm just copying whatever is the key that I've stored in this variable earlier. That's it. Nothing fancy here. Now let's go a little down. Okay, so let's go step by step now. Here there is some code. So I'll explain you step by step and carefully. I think there was a comment which said, can you explain how headers, everything works internally? I'll show you with this example. Okay. So first and foremost, because JSON, as I told you, is a very popular format for all of this, I'm importing JSON. We all know about OS. This is pretty print to print beautifully. Requests, right? So requests and responses are important packages that we can use. Okay. So imagine if my search query, the search query itself is Microsoft Cognitive Services. This is what I want to search. So if I go to Bing, look at this. If I go to Bing, if I just go to Bing, okay, funny. I'm going to Bing via Google, right? Microsoft search or cognitive services. What is it? What is the search? Okay. So suppose if I just search Microsoft Cognitive Services here. Okay. So these are all the search results that I'm getting here. I can get all of them through the API call. That's the best part. Okay, so let's go. So again, because we are implementing the API calling from scratch, there are a few important parts. The first one is called as headers. Remember, how does the whole thing work? We make a request and we get a response, right? This is the model, right? So that's why I've imported requests. So when I send a request, I have something called as a header. Within the header, all of the key important stuff, especially things like your API keys are stored, right? So the request that I send from my computer to the Azure computer. So this is the Azure computer. This is my local computer. So in the request that I send, I'm creating a header, and within the header, I'm saying my API subscription key. This part is important. This part is fixed for the key. All that, see, this I'm storing as a key value pair, if you think about it. I'm storing my API subscription key as this value, first and foremost, right? Again, when I send my request, I also send headers with it. Headers is a standard terminology in API calling, right? Headers typically contain the most important information like your keys. Okay, now comes the fun part. Now look at this. What am I loading here? I told you that all the request and response, right? All the request and response is happening through HTTP protocol. Request response. I mean, we're going to use HTTP protocol, URLs, all of that stuff, right? So I'm importing HTTP client, URL lib. What is the purpose of URL lib? It is because I'm using the internet protocols, right? URL is part of the internet protocol. This is to make a request. This is to parse if there are any errors and things like that. Again, I'm using JSON because my output is in JSON format. Okay, now look at this. This is my important function. My function is called search. Okay, so this function is where I'll actually make the call. So let's go step by step here. I'm just, till now what I've done, I've just imported everything. I've created a header. My header contained my key. Rest of it, I've just imported everything. Now let's go. This function is very important. So what are the three inputs to the function? Whatever is my search query, then there are two other parts, offset and count. Now imagine search results. If you notice, typically you get thousands of search results. Offset basically says, do you want us to return, or are you requesting for search results starting from 0th count? And how, see, offset basically says, which search result do you want? Do you want your search results to start with 0, which basically means the first, or do you want to start the search results from 100? So do you want results from 100 to, let's say, 110? If you want results from 100 to 110, what do? You say offset equals to 100, count equals to 10. You want 10 results starting from the 100th result, right? So this is how I'm defining my function. Okay, this is a local function. Remember, I have not yet called anything. So offset basically says at what count of the search result am I starting. Count basically says how many search results I want back. Simple. Now comes this. Now look at all the parameters that we want to pass. Again, remember, we have created our header. We have created our header in which we added our API key. Right? Now we are creating the parameters. In the parameters, again, parameters are stored as key value pairs. And I'm going to, see, look at this, the URL lib.parse. What am I doing here? I'm going to write them as key value pairs here, and I'm going to encode them using the URL lib, because the whole web APIs work using web protocols like URL, like HTTP, etc. So look at this. This is my query, my count, my offset. What is the market? Again, these words are given to me by Bing API itself. Bing API says whatever query you want to give it with Q. Whatever count you want, count, offset you want, what market, what results? Do you want results in India or do you want results in US? So the MKT basically means which market output you want. NUS, which means English in the US. Do you want safe search results? Right? If you want to be kid friendly, etc., you should make it safe search. The default is safe search is moderate. So what all am I passing here? My header contains the key, my params, right? My parameters contain everything else. And all this is encoded in the URL itself when I'm making the call. Right? So this part, basically I'm creating all of my parameters. Next comes the interesting, very, very interesting part. This, see, till now I haven't called anything. Now comes this try catch part or try exception. So look at this. So this is basically exception handling. If there is any error that happens here, I'll catch the exception and print it. Otherwise, what am I doing here? I'm connecting. What am I connecting to? I'm connecting to api.cognitive.microsoft.com. What am I doing? I'm doing a HTTPS secure connection. See, what protocol is it using? It's using HTTP secure protocol, which means my computer now is connecting to the API Cognitive Services Microsoft. My computer is now, my local computer is connecting to the server, and to which URL is it connecting? It's connecting to API cognitive.microsoft.com. It's connecting to this. Once it establishes a connection, it says my request now. It established a connection first, then it says I want to make a request, and this is a get request, which means I'm sending something and I want to get some data back. And what do I want to send this to? I want to say, what do I want to call? On this website, I want to go to Bing v7.0 and search. And what do I want to search with? All of my parameters that I have now, right? And the body is there, then all the headers. Why do I need headers? For authentication. Look at this, look at this line itself. First I establish a connection, then I make a request. Where do I request? I request to Bing version 7 API, and I'm saying search with all my search parameters that I have, all the parameters that I have, and I'm using the headers for authentication. Now what happens? Now look at this. First I established a connection, I sent a request, now I'll get a response back. So from this connection, I'll get a response. Now this response, I'm storing it in a variable called response. From this response, I want to get the data. So this data here is response.read. Once I got the response, I want to close the connection. Look at this, very simple. So what is the first thing? Establish a connection, establish, then request, then you get response. When you send a request, you basically say, I want to get this data, and what I want to call is the version 7 API with these search parameters, with these API keys. Once I get a response, I just say, let's close it. Close this connection. That's it. This 4 lines is where all the API magic is happening, right? Again, this is the native way of actually calling web APIs. What I've shown you with Google Google speech recognition is using a library. Within the library, they actually write code like this. Now I got my search results. My search results are in data. So how do I print my search results now? Look at this. This function returns JSON, loads data. This data it's going to convert into JSON and send it as my output. Right? Now let's see. Okay, now I got all my data in JSON format. Now I want to print it. It's very simple. Look at this. So look at this. I'm calling this search function. What is this search function now? This search function I'm calling now. Till now what have I done? I've just defined this function. I've not called anything. I'm calling this search function with my query, which is Microsoft Cognitive Services offset 0 count 5. After this, I get my output. I'm just printing them. So all this part is all about printing my results. Because my results are in key value pairs, I'm just printing my results here. This is just printing my results. Now, this type of printing is slightly trickier to read, because what is it giving you? It is giving you web pages outputs, the web URLs, all of that stuff. It is giving you related searches. It is giving you videos. It is giving you all of that stuff. But if you want to format this, look at this. Again, this is very, very hard to read. This is very lengthy because this is all in JSON format. You just have to write simple code in Python like this, through which you can print the data carefully. See, all this code is okay. My web search URL is this. Okay, what is my web search URL? Bing.com search. My query is Microsoft Cognitive Services. How many are the estimated matches? There are these many. 3. There are 50 million matches that are there. Right? Then, what are all the outputs that I have? Look at this. Is family friendly. These are all the URLs that I have. Again, you can just print. Again, the rest of the code here is all about printing the data. Look at this. All this is all about printing, because what I have is JSON data. Right? The data that I got from Microsoft Search back, all this code is all about just printing in each web page. So look at this. This is simple nested for loop here. Again, play with this. So what are we doing here? Look at this. Okay, let's look at this code. Okay. So I got my result. Look at this. So how did this work? Okay, let's go one step ahead. So my result is, I called this search function, I got my result, right? So within this result, if I want to print it beautifully, I closed it by mistake. Okay, I'll have to execute the whole thing. That's okay. We can, again, it's fairly simple. You can understand this. So what this does is, in the results for each web page, for each value, please print the information that I want, right? So you can literally get, okay, all the web page results and the descriptions also. You can also get videos. Okay, let's look at the videos, right? This is easy to understand. So in the results, there are videos. Pick all the items that you have. From each of them, again, we picked these, we carefully wrote this down to get this printing carefully, right? So these are all the search results that you get. Literally, I mean, you can print the way you want. Look at this. If you want videos, right? So it gives you all this information in the, okay, let's go through this. This is like a for loop. Again, this is similarly for video, very simple code. For video in results, okay, let me explain this code probably. That's a good idea, so that you understand the rest of the code easily. So our result is in res. Now I want the video results. I'm taking all the values for video in this, right? I'm getting key value pairs of all items in the videos. Now I'm basically printing this. So what do I get now? I get my web search URL. Look at this. This is the title. So when you do Bing search, right? Where is Bing search? Okay. Look at this. Okay, look at this. I search Microsoft Cognitive Services. What is my first result here? Real-time recognition with Microsoft Cognitive Services. This is a video result. Look at the result that we got here. The first result is real-time face recognition with Microsoft Cognitive Services. This is the name of the video. So you can get the name of the video. Look at all the information that we are getting. The description of this video. Okay, so I think if you just click on this, there is description also that you can get. Right? Then what do you have? You have thumbnail URL. Okay, the date on which this is published. The date on which this video was published. Look at this, Jan 17th. Right? So it tells you 2019 Jan 17th. Who is the publisher? YouTube is the publisher. Is this video accessible for free? True. Where is the video found? What is the video format? What is the length of the video? What is the height of the video? What is the duration of the video? I think it's 44 minutes something, right? 44 minutes 8 seconds. That's the length of the video. Look at this. It says 44 minutes 8 seconds. PT basically means play time. Okay. Look at all this information. The very first video result. What am I doing here? Microsoft Cognitive Search, Microsoft Cognitive Services, videos. This is the first result. All the information that is here is given to me in code. All of this is given to me in code. Right? So again, this is just all about getting the results and printing them. See what is this whole code doing? This whole code is simply printing the results beautifully. That's it. That's all it's doing. Okay, in a readable format, not in a JSON, which is slightly trickier to read, but JSON is also easy to read. Now, whatever we have done, we can also do it for images also. Again, there is this very nice page that I forgot to talk about. Okay. So what you can do here is, look at this, Bing web search, you can try it in action. I really like this. So for example, okay, so there is this default one. So if you want to try how it works, again, this is the Python way of doing it, right? There is something called as Azure Playground. So in Azure Playground, again, I'll provide this link to you, Bing web search API. So what you can do is, whatever search query you give here, and you can give the markets. You can say English, India. You want strict safe search. Do you want freshness? Freshness also is another parameter that you can give. Do you want results only from the last 1 week? Look at this. The moment I give these search results, the JSON file that I get is actually looks like this. Let me zoom this in a little. The JSON file that I get actually looks like this. What we have done in this is basically print the JSON file in a way that you can easily read. So if you actually call Bing API with this burrito recipes, burrito is a Mexican delicacy, right? Or it's something like a roti, like roti curry. The way we have roti curry, burrito is a Mexican food item. If my search query is burrito recipes with English, India, safe search being strict and freshness being 1 week, then what do I get? When I call this function, look at this. When I call this whole, again, most of this code is not lengthy. Most of this code is only outputs that you see. The core part of the code is just this. This 20 lines of code is the core part. This 20 lines of code. Literally this 20 lines is the core part of calling the API. That's it, right? So the JSON file that you get is like this. Again, there are direct JSON readers. You can read this file and print it the way you want. Look at all the data it gives you. it tells you what are the estimated matches, right? Then what is the first output, what is the ID, how did I call this, okay? When was this page crawled by Bing? What is the name of the web page? What is the URL? And it also gives you a small snippet. Look at this. If I go to Google and search, if I go to Bing and search this burrito recipes. Okay, look at this. So it gave me this, and this is the description part. So what it's giving me is, it's giving me the title, it's giving me the URL, it's giving me the text. It's also giving me other information like when was this page crawled by Bing, right? Because most likely Bing would crawl just a few days after, or maybe very soon after the page was created. Bing as a search engine crawls all this, right? So look at all the results that you get. Now your big question could be, why do I need Bing Search API? I'll tell you something very interesting. Let me give you an example. Okay, suppose you're training a deep learning model. Let me give you an example. Suppose you're training a deep learning model, and you want, let's say, images of knife, right? You want images of knife, let's say. Okay, you don't have enough images. How do you get all the images of knife? You can go to Google search, but how do you download these images of knife? This is important, right? How do you download these images of knives? Because suppose you want to build a model for some safety or whatever. Suppose there is a camera that, let's assume at a school, if anybody is carrying a knife, or a place of worship or a sensitive place, anybody carrying a knife, it should simply stop that person, right? Or a gun, knife or gun, whatever you want, right? Which means you need images of knife or gun to train the model. How do you get this data? It's very simple. You just have to call Bing Search API with image search. So what we have done till now is web search, right? We can write similar code for image search also. Let me show you. Okay, so query 2, 1 second. So you can also search for persons. Suppose if you search with my name, right, you will get both. Again, you can just call search with my name here, right? And what you get now is basically, you can get my images also. Okay, it also gives you alternative spellings. So my original query is, let's say, what did this, okay, I think my team forgot to put H here. So if the original query is Srikanth Verma Chekuri without a H, it says there are alternative queries with H. So it is sort of like correcting, right? Small v, capital V. So small c, capital C. It also tells you alternative queries that you can get. So what Bing Search API gives you is tremendous amount of information that you can use. Now we also have done, again, I recommend that you go through this line by line, but most of what we have from here is simply about these for loops that we have shown and printing some data that you can see. Basically that's what, once you call the Bing API, get the data, you just have to print it in whichever way you want. Now let's see if we can do the same thing for images also. Okay, images is very interesting. So I think we implemented a function for images. Where is that query context? Bing Search API, query 2, web pages. Just give me a second. Bing Image Search API. So what have we done here? Again, this is for image search. The code is very similar, except that we also import a library called image because we want to play with images, right? Look at this. We are writing a function called show image where we are using matplotlib. PLT is matplotlib, right? We have imported matplotlib as PLT. We have also written this function called show image to show an image actually, right? So if I have any image, I can actually show that. Given a URL of the image, this show image function, let's see what it does. Let's go step by step anyway. The show image function takes the URL and the title of the image, right? So again, here what am I using? What am I doing here? Request.get. I'm sending the URL using the request response model because that's what the internet uses, right? I'm going to get whatever is there in this URL. I'm going to get that image. This is the image URL. I'm going to get that output, store it in the response. Now look at this. Whatever is there in the response, I'm going to convert it into image using my PIL. From PIL, I'm importing image. So image.open response.raw. So this basically gives me an image. IMG is now the image. Now I can plot the IMG using my matplotlib IM show. Right? So what this function does is, given a web URL, it uses the request response thing that we have discussed, right? It requests from this URL to get the image, and it loads this. So whatever is the output that I got, this is a binary output that I have, right? It converts that into image using image.open, then it plots the image. That's what this function does. Now there is a second function that I am defining. It's called search images. Again, the search images is exactly like the search function. Look at this. I have a query, I have offset, count, I have my parameters, I have my connection establishment. This logic is exactly the same. Look at this. This logic is exactly the same. The only difference is I am using images, then search. So I'm going to API cognitivemicrosoft.com. But when I'm requesting for something, I'm saying I want to get the data that is there. And where do I want to get it from? Bing version 7.0 images. The only difference between this function and the previous function is this function has images, the previous function does not have images. The moment you have images here, what you're doing is an image search. Rest everything is the same. You have the parameters, you have the headers, everything the same. You establish a connection, you request for the data, you get a response back, and you close the connection. That's it. Now when you get the image, look at this. What is this giving you? This web search, this image search gives you image URLs. So suppose if you write this code, right? Suppose if I search for Bill Gates as my search query, offset 0, count 4. Right? From the results that I'm getting, I'm just printing them. What does this give me? It says, okay, look at this. Let me just go ahead. It gives me URLs. It gives me web search URL. This is the search URL. Or else if you expand this and print it carefully, what it gives you is, okay, this is the search URL. What is the search URL? Bing.com, images, search, blah, blah, blah. Right? Where is the thumbnail? Here is the thumbnail. So if I go here, open link in new tab, this is, I think this is Bill Gates' home if I'm not wrong. Okay, this is one of the outputs that I get. Okay, this is query expansion because the search here is Bill Gates' house. Right? It also, see, what Bing also gives you is, Bing says related searches. If you go to Bing in general, right? Look at this. If I search for, let's say, Bill Gates. Okay, let me search for it. Bill Gates images. It tells me other things about Bill Gates that people search for. Steve Jobs, Bill Gates' childhood, Bill Gates' yacht, Bill Gates' net worth, William Bill Gates inventions, Bill Gates' son, all this stuff. These are all related searches, right? So Bing also gives you that. Where were we? Sorry. Bing also gives you all that. It gives you Bill Gates sayings, Bill Gates quotes, Bill Gates references. So you can get all this as part of your search result also, right? So it also gives you, like for example, the Steve Jobs, right? These are called as pivot suggestions. Again, there is a huge amount of data that Bing throws at you, right? You just have to process them because if you look at your response JSON, the response JSON that you get, it's actually huge. It gives you web search URL, it gives you query context, it gives you tons of data. Look at this. In query expansions, this is the output JSON that we got, right? In query expansions, it tells you other similar search items. Pivot suggestions, it tells you about Bill Gates. People who search for Bill Gates also search for Steve Jobs here. Look at this. Look at that line, right? Again, it gives you multiple links. People also search for Melinda Gates, who is Bill Gates' wife. Right? It gives you, so Bing Search API gives you a lot of data that you can use. Of course, now where are the images? So let's go a little down. These are pivot suggestions, related searches. Again, image search results. Now look at this. So I'm taking the thumbnail URL. Look at this. What is this code doing? This code is saying whatever is the result that I got, whatever is the result JSON that I got, within that go to value and show the image of the thumbnail URL. See, show image function we have seen a while ago, right? It says show image, print or show the image of the thumbnail URL. So it shows the image. Then I want to print a bunch of data again below that. So what does it say? Look at this. Okay, 1 second. Let me go down here. Okay, so this page has become a little small. So let's look at this printing code, right? Again, I'll show you one printing code, rest everything looks the same. First, in my results, I want to go to the values, right? In the val, look at this. This is a for loop. This is a for loop. Within that, there is one more for loop. Within this for loop, I'm calling this function called show image. Whatever is the result or the value, thumbnail URL, show it to me. I'm showing the thumbnail URL. then whatever other information is there, just print it. So if you actually scroll down here, what do you get? You get the image URL, you get the web search that you got. What is the name of this image? Bill Gates net worth, 5 fast facts you need to know. The thumbnail URL, when was this published? Is this family friendly or is this objectionable content? What is the content URL? What is the content size? What is the format of the image? What is the width of the image? What is the height of the image? What is the thumbnail width? What is the thumbnail this thing? I mean, accent colors. So tons of information that it gives you just for one result. This is one result, right? Of course, because we have put everything in a loop, right? You will print all those. I think we searched for 4 results. This is a second thumbnail image. Again, what is the name of this? Blah, 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 blah. All this information that you get. Very simple. Again, all of these code snippets that we have here are mostly meant for printing the data of the results that we got. So don't get overwhelmed by this. Just go through this line by line. I've explained a couple of them. Rest everything is the same. This sheet might feel long, but because the results are long. Okay, this whole thing, when I start printing this information, because I wanted to print it carefully for you. The size after I print looks large, but the code itself is simple for loops, right? There are literally 2 major functions. One is the image search API function that we have done, show image, and the regular search. That's it. Again, this whole printing function, you can write it the way you want. We have written one of the ways that we could think of, right? It's all about just printing the results. All this is just printing the results. Now, okay, so as we thought, you can use the image search API to collect data of a specific person. For example, you can collect images of cell phones, or you can collect images of weapons like guns or knives, etc. Right? So again, the whole purpose of this was, okay, so 2 things. Just let me quickly recap what we have learned. So in the Bing search API, we have learned both the web search and the image search. We have learned how the API calling itself works from scratch. That's very important. Using the request response connection, right? Using connection, request, response. That's the most important part. My results, I get it in JSON format. Then we have written some print commands to print the output in a easy to read format. That's all we have done, to be honest with you. It's fairly simple. You can do this. You can do all of this in an afternoon. Actually, this was one of the live sessions for which I took the least amount of time to prepare. I think even the team has taken least amount of time to prepare, because this is so easy from a coding perspective, right? So that's the key takeaway. So I hope you have gotten a sense of how to use Google API and Bing API. Let me just change the screen to the webcam quickly, and let me answer a few questions that you may have, because so somebody says, can't we use request module for Google as we use it in Bing? Yes, you can. You can see, we wanted to show you 2 ways of doing it. Okay, we want to show you in the speech recognizer part, we have actually used another library that takes care of establishing the connection, request, response, all of that. That's one way of doing it. The other way, the way we have shown it with Bing, is to do the connection part yourself, establish the connection yourself, send the request parameters, headers yourself, get the response, process it yourself. Right? We want to show you 2 ways on 2 different. The Google one, you can write it using the connection, request, response, header. You can do it yourself. You don't have to use the speech recognizer thing. But we want to show you 2 ways of doing it. Even for Bing search, I think there is a Python package. Let me just share the screen and search it right in front of you. Bing search pip. See, look at this. Bing search. Okay, so you can just install this package called Bing search. I just Google search right now. You can just say pip install Bing search, and the function calling will be trivial. Look at this. Look at what, they'll give you some small snippet of code like this. Where is this? Okay, look at this. So, okay, look at this snippet of code here. From Bing search, import Bing web search. The search term is Python software foundation. Web is, just call this. That's it, done. You're done. You get all your results, right? So there for most web APIs, there are also libraries so that you don't have to establish the connection and do everything yourself. So that is also there. But we want to show you two different ways of doing it. One using pre-existing libraries, one doing it from scratch. Do we need to import any certificate of backend system when we are calling? Like for example, in the Google system, right, we have used the API, the JSON file, the API key.json. We send it as part of our request to the Google server. Similarly for Bing, we had this alphanumeric API key that we sent. That's good enough. Again, different web APIs have different ways of doing it. Some of them also have a file that you need to have on your computer and things like that. The simplest is basically passing the JSON, the API key file or the API key itself as part of the headers. Oh, somebody says, okay, can't I download an image directly from Google? Why do I need an API? Very good question. So the problem is, if you try to manually download images, how many can you download? It will take you tons of time to download these images. You want to write a program, leave it overnight, get all the data you want, next day you can train. Manually doing it is just too cumbersome, number one. Number two, the other alternative is, we have done a live session on that also, which is web scraping. Why can't I web scrape the whole damn thing? I can write Python code using a web scraper, using beautiful soup, scrape the whole damn thing. But then most companies like Google, Bing, etc. will block you. The moment they realize that you're trying to scrape their search results, they'll block you. And that is the unethical way, because Google doesn't want you to scrape their search results and Bing also doesn't want to scrape their search results. It's an unethical way of getting it. And they're fairly smart, they'll block you in no time. Right? The legit way or the reasonably correct way is to use these APIs, because these APIs are provided by the companies. For example, as part of our codes, right, we have this Amazon products or Amazon fashion search that we have built. Now, how did we build that? How did we get the data? I think we have a few 100,000 images for that. We didn't crawl from Amazon because we know Amazon will block us. So Amazon also has something called as Amazon Product Advertising API, through which you can go and get images from Amazon. We've actually done a case study on that, right? We have done a live session on how to scrape results, but please don't scrape. If there is an API available, please don't scrape the web. Use the API, that is a legit form of doing it. And it took us like a week to get, because Amazon says you can't do more than these many requests per day or per hour. So what did we do? We waited for a week, we got like 100,000 plus images and we built a fashion recommendation system. This is part of our case studies actually, right? Is Google Colab a free tool? Yes, as of now it is free. It works fairly well also. Again, we did not use Google Colab extensively when we designed the course earlier because it was not stable then. But nowadays it's becoming very stable, and we are also sharing Google Colab notebooks to our students. All the new stuff that we'll be doing, we'll start sharing Google Colab notebooks. And again, you can take a Google Colab notebook and make it into an IPython notebook, Jupyter notebook or IPython notebook and run it on your laptop or desktop also. Can you send keys in params? Yes, you can. Again, every web API has their own small glitches. You'll have to read the documentation carefully, right? You have to be slightly careful. Like the way Google might say, this is how you have to. Again, most of these companies will give you sample code. You can call web APIs in any programming language. You don't have to use Python. I know people who call them in JavaScript. People can call it in Perl. People can call it in Ruby. That you can call it in many languages as long as the language supports internet protocols. I know some people who call it even in C++ by importing some internet-based libraries like HTTP, HTTPS, etc. You can call it from Java. You can call it from any major programming language as long as the programming language supports internet protocols. Now, the most important thing here is how to call that exact API using your programming language. Most companies provide you sample code. Like for Google, AWS, Azure, you get sample code. You just follow that sample code. It's much, much quicker. Yes, you can do it for Facebook API, Twitter API, Netflix API, you name it. The exact format of the API, the keys, look at this. Google had an API JSON file. Bing had just an API key. So for every cloud-based or web-based API provider, there is a subtle difference. There is a small difference in how you pass keys, how you pass parameters. There is a subtle difference, but if you just read through the documentation, it should be straightforward. So somebody says, is OpenCV useful in real-time projects? Why not? There are a lot of computer vision stuff for which OpenCV is used. Of course, if you're talking specifically about object recognition tasks, deep learning is the cutting edge. But again, we have done a couple of case studies around images and video in our course. We have used OpenCV primarily to pre-process our data. For example, we have used OpenCV to take images, resize them, convert them from color to grayscale. All of this simple image pre-processing, you can do it very, very efficiently in OpenCV. There are some, okay, OpenCV is not just image pre-processing, there is also multi-view geometry, etc., based on which I did a startup earlier in 2010 where we used some of those technologies. So don't write off any library, especially a big library like OpenCV, because you can do some really fun stuff with OpenCV. Okay, but if you want to do object recognition type stuff, it's better to use pre-trained models in TensorFlow or Keras or PyTorch. How do I learn to create APIs? Very good question. So actually we have done a live session earlier. That's why I didn't want to repeat that in this live session. So if you know Python, there is something called as Flask. Just Google search for it. It's extremely simple to learn, right? Flask is the primary library that is used to create APIs in Python. So we have done a live session. I don't remember whether it is a public live session or only for a registered students. I don't remember it. I've done it like almost a year ago, I guess, where we have taught how to build a web API using Flask and how to deploy it on a AWS computer. But it's fairly simple. Even if you're not a student, just Google search for it, read about Flask, right? Flask is the important part. Flask, again, just search for how to build web API using Flask in Python. You'll get tons of tutorials. It should be easy. If you know Python, it should be simple. So somebody says, should you use Flask or Django? You can use either of them. They're just two different ways of doing it. You can use both of them. They both work very well. I prefer Flask personally because Flask is much more lightweight, mostly designed for web APIs. Django is a full-fledged web development platform. Right? If you want to develop a whole website, backend of a website, Django is like a very powerful software. So Django's purpose is much bigger than Flask. Flask is very limited to mostly creating web APIs, basic request response type stuff, while Django is a much bigger platform or much bigger library. So that's why it's easier to use. That's why I prefer Flask. But if you know Django, please feel free to use Django. Again, somebody says, do we need to learn object-oriented concepts to start learning Flask and Django? See, object-oriented programming is a big area. Okay, it's a massive area. What you need to know is the basics. You need to know what is a class. You need to know what is an object. You need to know what is a constructor. You need to know how to call functions within a class. If you know this, maybe you might have to know a little bit about inheritance. A little bit. Okay, you don't have to know advanced concepts about object-oriented design, all of those advanced topics you don't require. If you know the basics, you can learn. Again, if you know these concepts from any programming language, if you know, let's say, classes, objects, basics of inheritance, basics of what is a constructor, how do you call functions within a class. If you know that, even in Java, you can learn that. You can start learning any object-oriented language. If you know it in C++ also chalega. Python is slightly different in some aspects. But to learn Flask and Django, you don't have to be an expert at object-oriented design patterns, all of that you don't have to be. You just have to know the basic stuff. So somebody says, very good question. So APIs can be called either using HTTP or HTTPS. Again, it depends on the designer of the API. S basically means you get a secure layer on top of HTTP. So everything is encrypted and things like that. But anyway, I mean, again, it's a choice that the API designer chose, right? You can have HTTP based APIs or HTTPS based. The only major advantage of the HTTPS based ones is it's a more secure connection. Everything is encrypted and things like that, right? So to be a machine learning engineer, do we need to be a master in core Python? So I don't know what core Python is, but at least you need to know the basics. Let me tell you what you need to know. As far as Python is concerned, you have to know basic if-else, variables, basic data structures like dictionary, list, basic data structures. Okay, you have to know basics of for loops, while, function calls, function parameters, returning from a function, what is a class, what is an object, what is a constructor. If you know these concepts and if you're comfortable with programming, if you can write like decent nested for loops for a given task, I think that's good enough. Of course, you have to learn other libraries for machine learning, right? You have to learn matplotlib for plotting, you have to learn pandas for all data related stuff. To load data, you have to learn numpy, scipy for basic mathematical transforms. You have to learn scikit-learn for basic machine learning algorithms. You have to learn TensorFlow, Keras for deep learning stuff. But libraries come and go, right? Libraries come and go. If you're like, I've learned Python long ago. Libraries came, libraries went. But the most important part is I know how to write basic, decent Python code. Again, I'm not an expert in software development, like huge scale software development like some of my principal engineers or senior engineers at Amazon, but I can do decent work. So my knowledge of Python is good enough that I can learn and pick up a new library that comes. That's good enough for all practical reasons. Is security necessary for API in machine learning? That depends on the company that's implementing. For example, some companies might say we want to use HTTPS for security because this is more like anyway your API key itself could be encrypted end to end and things like that. But equally important, they might say there is sensitive information like audio, so we want to encrypt it. All that stuff, it's a decision of the API designer. Okay, sounds good, folks. I think speech to SQL queries. Can we do this using API you taught us today? No. So of course, if you say SQL specifically, if you clearly say select star from so and so table, blah blah blah, join this that. If you say that in English, I think it can do a decent job. But again, remember that Google speech to text is not trained on SQL queries per se. But I think speaking out SQL queries is very hard. I mean, at least I can't think of it. I'm better off writing it and seeing what I'm writing, what I'm typing, correcting it as I go. I can't close my eyes and read off an SQL query at the top of my head. I don't think I can do it. So, okay, somebody says, what is TensorFlow? Okay, so again, TensorFlow is a open source deep learning library built at Google, open sourced, used extensively in deep learning. So if you ever end up learning deep learning, TensorFlow might be one of the most important libraries along with Keras and maybe PyTorch that you should learn, right? Okay, sounds good, guys. All the very best. And I think we've had a good session. Thank you one and all for your time. But please give me a few hours time because I need to sanitize our IPython our Colab notebooks. I will provide the Colab notebook links so that you can copy them, use it on your drive. I'll also provide the key folders, the key files and the folders that you need to run, especially the Google speech to text, the Google speech to text one, which is basically your requirements file, your parts folder and your audio file. Right? API key I cannot share because it is ours. You'll have to create your own API key.json and put it in that folder, right? So anyway, I'll put it, just give me some time. By evening, I'll do that. Couple of hours, give it to me and I'll do it. See you folks. Thank you very much. Thank you very much for your time and yeah, bye-bye.